Our final example in this section is solving application problems that involve a linear inequality. So to do this, we're going to be using the same steps that we've used when we were solving application problems for linear equations. We're still going to read the problem, make notes, define a variable, translate the story into a mathematical statement, solve it, check it with the story. But as we're doing that, we're also going to keep in mind the new rules that we added for inequalities. The only one of which was that if we divide or multiply by a negative, we have to change the direction of the sign as we're solving it. Otherwise, the rules are going to look just as they did for solving story problems that are linear equations. So let's start this. Keisha is planning a baby shower for her sister. The restaurant charges $350 for the first 20 people, plus $14 for each additional guest. How many people could attend the baby shower if Keisha can spend at most $650? So they're charging her $350, and that includes all of the first 20 guests. So 20 guests. Plus, they charge $14 for each guest after that. And we want to know how many people can attend if her top budget, the most that she can spend, is $650. That means that her total has to be either less than or equal to $650. So let's try this. They're starting with $350. They're going to charge that off the top, no matter how many guests she has. This is the base charge, and it includes 20 guests. They also charge $14 for each additional guest. And we know that the total cost for the shower has to be less than the total cost needs to be smaller or equal to $650. So we've read through the problem, we've made some notes. Now we need to define a variable. Well, I'm going to choose the variable G to stand for guests. And I know that included in this number of guests that I get 20 of them for the base rate. So I'm only paying this $14 for my number of guests that goes over the 20. So I only pay the 14 for the guests that are higher, the guests that happen after those first 20 guests. So Keisha will spend $350 plus $14 for each guest after the initial 20. And this total cost here needs to be less than or equal to the $650 she has budgeted for the party. We'll use our regular algebra skills to solve this problem. So I'm going to distribute the 14 through. 14 times 2 would be 28, so this is going to be 280. And then I combine my like terms. The 350 and the 280 is going to leave me with 14G plus 70. I'll subtract 70 from both sides. So 14G is equal to, it looks like 580, and then divide both sides by 14, which I'll come over here and do on the edge. 580 divided by 14, 28, 38, 42, 52, 56, so it looks like it fits 4 times, with 2 left over 1 more time, and then there'll still be a remainder of 6. So I get 41 and 6/14, which would reduce to 3/7, is what is, oops, I switched my sides. Sorry about that. The G is what's left on this side of the inequality, and since it's an inequality, it matters. We can't just switch the sides. So the G has to be less than or equal to 41 and 3/7. Then we go back to the context of the problem. It's not really possible to invite 3/7 of a guest. You either invite a guest or you don't invite a guest. And since the G needs to be smaller than this total number, and it can't equal this number, our highest number of guests is 41. When we check that, back with our original problem, the restaurant's going to charge $350 for the first 20 guests, and then another $14 for each guest over that 20, those initial 20. So if we think we can invite 41 guests, 20 of them are already covered in that original $350. So we're paying this $14 for the extra 21 guests that we invite. We're going to double check the math here. That's 9 and 2. So those additional 21 guests are going to cost Keisha $14 a piece. We add that $294 that she's spending for those guests to the $350 that they charge as the flat rate for the first few guests. And we get a total of $644. So even though her budget went up to $650, because adding that 42nd guest would put her over budget, we're going to stop at $644, and she'll have $6 left to buy door prizes or something like that. So our final answer to the question is that her guest total, our guest, maybe we should call that count, is 41. And she's going to pay a total of $644 for those guests.